Alaikum and hi everyone. Okay, so in this video I'm going to show you on how you can write down the names of your alkane correctly based on the IUPAC name. So these are the summarized 4 steps that you need to follow whenever you try to name your alkane. Okay, basically this 4 steps rule is applied to any of the organic compound that you're going to see throughout the semester too. Okay, so you always need to start by identifying your parent chain. Okay, so your parent chain should have the longest carbon chain. Okay, and then you need to number your parent chains according to the prefixes as you can refer in the lecture note. For example, if there are 7 carbon, then we're going to name it as heptane. If it is 5 carbon, then it is pentane, and so on. Okay, and you need to identify the substituents that is present in your alkane. Alright, so if you have more than one type of substituents, you need to arrange your substituents according to the alphabetical order, and that set of substituents should have the lowest set of numbers. Okay, there are 2 types of substituents. We have alkyl group substituents, which is a straight chain alkyl groups, or we might encounter to a special kind of substituent, which is your branch alkyl substituents. Okay, and once you are done with all the first 3 steps, okay, now you are able to write down the names of your alkane, and you need to make sure the names of the alkane is written in a single word. So we're going to use comma to separate numbers, and we use hyphen to separate the name of the substituents. Okay, I'm going to show you several examples to guide you on how to give names of your alkane. Discuss on special kinds of substituents, which is your branch alkyl substituents. Okay, so there are 7 types that you need to memorize and understand. Okay, so the first one is isopropyl, which it looks like this. Okay, so it's CH, and then we have here CH3 and CH3. So this isopropyl is made up of 3 carbon, so that's why it's propyl, and iso is referring to this CH3 at both sides of your CH here. Okay, so that's why it's isopropyl. Okay, if it's isobutyl, that means we need to have extra carbon, which is your CH2, CH, okay, and then we have here CH3 and CH3. So 4 carbon made up your isobutyl. Okay, so secondary butyl, that means we have 4 carbon in your substituents, but it's secondary. When secondary, that means, okay, this parent chain is attaching to the secondary carbon of your substituent. So we have here CH, okay, so it's CH3, and then CH2 and CH3. So that is your secondary butyl or sec-butyl. Okay, so let me highlight it. Okay, and the last one is third butyl. Okay, so third butyl means this carbon and your parent chain is attached to the tertiary carbon at your substituent. Okay, so this one looks like this. So CH3, CH3, and CH3. So that is your third butyl. Okay, if I highlight it, it will look like this. Okay, it looks like a T shape. Move on with a substituents that have 5 carbon into it. So we have here isopentyl, neopentyl, and terpentyl. Okay, let's discuss on isopentyl. Okay, so that means there are 5 carbon at your substituents. Okay, so it will have here CH2 plus CH2, the second carbon, another CH, okay, at your third carbon, and then we have here CH3, which made up the iso compound. So 1, 2, 3, 4, 5. So that is your isopentyl. Okay, so neopentyl is more like your third butyl, alright, but with addition of extra CH2. So here we have CH2, and then here C, and we have a tertiary carbon. Okay, so this is your neopentyl. Okay, and lastly is your terpentyl, which means your carbon at your parent chain is directly attached to the tertiary carbon in your substituents. Okay, so here we have C and CH3 and CH3. Okay, and then the remaining goes here, so CH3 and CH3. So that is your third pentyl. Okay, so the special kind of substituents are actually branch type of alkyl groups, and you need to memorize. Okay, so the normal one is just a straight alkyl group, which is, for example, we have here the backbone. So here, so this only one, so that means it's CH3. So this is methyl. Okay, let's say I have here C and then 1, 2, so 2 carbon. So this is ethyl. So that is a straight chain alkyl group in your substituents. Let's first, okay, we draw skeletal structure based on the given name of your alkane. So here we have 5-isobutyl 2,4-dimethyl octane. So it's octane, so that means it's made up of 8 carbon at the backbone. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, at the carbon number 2 we have methyl, so methyl here 1, and at the carbon number 4 we have another methyl, so this is 2,4-dimethyl. Okay, and at the carbon number 5 we have isobutyl, so that means here it's C1, 2, 3, 4. So that is your isobutyl. Okay, so that is your 5-isobutyl 2,4-dimethyl octane. Okay, so let's move on to the second exercise. Okay, so the second exercise asks you to draw 1,1-diethyl 3-butyl cyclopentane. So that means your backbone is cyclopentane. So let's draw a cyclopentane. Cyclopentane is a cyclic alkane with 5 carbon. Okay, so this is your cyclopentane. Okay, so let's number it first as a guidance. So first, second, third, fourth, and fifth. Okay, so at your first carbon, you will have 1,1-diethyl. So diethyl is a CH2 and CH3. Okay, so CH2, CH3. Okay, at the third carbon, you will have third butyl. Okay, so third butyl looks like this. C, CH3, CH3, so CH3. So that is your third butyl. So this is the molecular structure of your 1,1-diethyl 3-butyl cyclopentane. Okay. If just now you were given an IUPAC name and you need to come up with the skeletal structure, in this one I give you skeletal structure and you need to come up with the IUPAC name. Okay, so let's follow the step. The first step, you need to find out where is your parent chain, which is the longest carbon chain in your molecular structure. Okay, so highlight it 1, 2, 3, 4, 5, 6. So there are 6 carbon at your parent chain. That means this is your hexane. Okay, so there are 3 substituents. Okay, at the carbon number 1, 2, 3. Okay, so the first substituent is at the carbon number 2, which is your ethyl. Okay, because CH2 and CH3, so ethyl. And at the carbon number 3, there are two same substituents. Okay, which is here is CH3 and another CH3. So that means at the carbon 3, you have 2 methyl group. Okay, so let's write down the full name of your compound number 1. So we need to arrange them according to the alphabetical order. So ethyl comes first, followed by methyl. Okay, so it's 2-ethyl. Okay, so this hyphen is to separate numbers and names. Okay, 2-ethyl, 3,3-dimethyl. Why di? Because we have 2 methyl substituents. Okay, 3,3-dimethyl hexane. Alright, so let's move on to the second question. Okay, let's highlight first the main backbone. Okay, which is the longest carbon chain. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is 8 carbon at the backbone. So that means this is an octane. Okay, so let's give a number. So 1, 2, 3, 4, 5, 6, 7, 8. So if I number my compound from the bottom here, so my substituent is located at the carbon number 3, 4, and 5. Okay. But if I number it from the top, 1, 2, 3, 4, 5, 6, 7, 8. So my substituent will be located at the carbon number 4, 5, and 6. And which one will give the lowest set number? Okay, so we will find out later on. Okay, but first let's identify the substituent that is present. Okay, so my first substituent is here, which is methyl, and another one here, which is also a methyl substituent. Okay, so here is CH2, CH3. So this is ethyl. Okay, so whenever we want to write down the name, we need to arrange them according to the alphabetical order. Okay, so first side, okay, if I numbers my backbone from the bottom, okay, so it will have 5 ethyl, okay, so 3, 4 dimethyl octane. Okay, so secondly, if I start number it from here, from the top, I will have 4 ethyl, okay, 5, 6 dimethyl octane. Okay, so in the first one, okay, I have 5, 3, 4. Okay, so 5, 3, 4 versus the second one, 4, 5, 6. Okay, so 4, 5, 6 is the lowest set of number. Therefore, okay, the second name is accepted. The first one is rejected. Okay, so the compound 2, the name for the compound 2 is actually 4 ethyl 5, 6 dimethyl octane. Okay, let's move on to another example. Okay, so here I'm going to find out which one is the longest carbon chain. Okay, highlight it. So 1, 2, 3, 4, 5, 6. Okay, so it becomes 1, 2, 3, 4, 5, 6, 7. Okay, or I can number it from the right, 1, 2, 3, 4, 5, 6, 7. Alright, so if I numbered my compounds from the left, okay, so my substituents will be located at the carbon number 6 and number 5. But if I numbering my backbone from the right, so I might have my substituents at the carbon number 2 and number 5. So definitely the one numbering from the right has the higher priority because it will give you the lowest set of number for your substituent. Okay, so my substituent here is first, it is methyl, okay, at the carbon number 2, and at the carbon number 5, this is my ethyl. So this compound, so this compound is actually 2 methyl, okay, so 5 ethyl heptane. Okay, alright, so let's move on to another example. So here we have a cyclic alkane, and this cyclic structure is made up of 6 carbon. So this is cyclohexane. Okay, hex means for 6 carbon. Okay, so I have two substituents here. So this is the first one and this is the second one. Okay, so my first substituent is actually an isopropyl. Why do I say so? Okay, because if let's say we write down the formula, so CH and CH3 and CH3, which looks like a chicken feet, so it's isopropyl. Okay, and then I have another substituent here, which is your methyl. Okay, so I'm going to start numbering from the first substituent, so first, second, and third. So this compound has the name of 1 isopropyl, okay, so 3 methyl cyclohexane. Okay, so isopropyl is I and methyl is M. So according to the alphabetical order, I come first, then M. So therefore, it's 1 isopropyl 3 methyl cyclohexane. Okay, and let's move on to the next question. Okay, so I have another cyclic structure, which is my cyclopentane, because it's made up of 5 carbon. Okay, so cyclopentane as my parent chain or my backbone or my longest carbon chain. Okay, so there are 3 different substituents here. So this is the first one, which is ethyl. Okay, and the second one here, I have a cycloalkane as the substituent, and it has 3 carbon. So that means this is cyclopropyl. Okay, and there is another one substituent here, which has 1, 2, 3, 4. Okay, so so it has 4 carbon, so it's butyl. Okay, but okay, the carbon at my parent chain is attaching to the second carbon of my substituent, so this is sec-butyl. Okay, so it's a special kind of branch substituents. Okay, so let's write down the name. The numbering should start from this sec-butyl because this one is B. So B comes first compared to ethyl, which is E. So instead of numbering from ethyl here, so I will start to number from here 1, 2, 3. Okay. So the name of this compound is 1 sec-butyl. Okay. 2 cyclopropyl. 3 ethyl cyclopentane. So it's such a long name. Okay. Okay, so let's look at the last question. Okay, so you have given 1,2,2 trimethylpropyl cyclohexane. So that means your backbone is your cyclohexane. Okay, so let's draw a cyclohexane, which is a cycloalkane with 6 carbon. Okay, and then we have here 1,2,2 trimethylpropyl. So that means it's a propyl. So propyl is CH. Okay, CH and CH3. Okay, and at the carbon number 1 we have methyl, so CH3. Okay, 1, 2, 3, 4. Okay, and then 2 trimethyl. So that means instead of CH here, I only have C and CH3. Okay, so C and CH3 at the end. And at the carbon number 2, I have 2 CH3. Okay, so this is the substituents, which is your 1,2,2 trimethylpropyl. The main is the propyl here, but there are 3 methyl groups attached on your propyl, which is at the carbon number 1, carbon number 1, and 2 at the carbon number 2. Let's recap. Okay, so whenever you try to name your alkane or basically to any other organic compound later on, okay, so you need to first identify which is the longest carbon chain, which will serve as the parent chain or your backbone. Secondly, you need to number your parent chains, okay, according to the prefixes given, and then you need to identify the substituents. Okay, so normally we will have more than 1 substituents in your alkane. Okay, so you're going to arrange the substituents according to the alphabetical order first, and secondly, you need to make sure it have the lowest set of number. So for example, it's 546 versus 276, so definitely 276 will win because 2 is smaller than 5. Right? And lastly, you need to make sure you write down the names of the compound in a single name. So we use comma to separate numbers, and we use hyphen to separate the name of the substituents. Okay guys, thank you for watching. Bye bye.